July 21, 1904, Guam, Mariana Islands. Engines roared across the partially cleared jungle airstrips, vibrating through steel concrete and the wooden scaffolding of hastily constructed runways. Smoke from diesel trucks and machinery mingled with the humid morning air, wrapping the Seabees in a veil that blurred the outline of distant hills. Every crew member moved with a precise rhythm, boots crunching on gravel hands, gripping tools, eyes scanning the horizon for enemy observation. The Japanese defenders entrenched in bunkers and hidden positions could hardly believe what they saw. Airstrips appeared with astonishing speed, bulldozers, graders, and cranes moving in synchronized chaos, transforming dense jungle into operational runways in days. Reports later described their shock airfields constructed under fire with unbelievable speed, impossible to target before operational. A single order could cut through the noise. Clear the area, lay the matting, prep the runway now. And the Seabees obeyed with disciplined precision, their training evident in every motion. From the pounding of steel to the hum of engines, each sound marked progress. Each vibration carried both urgency and triumph. For the Japanese, it was a revelation. They had expected Allied engineers to move cautiously, delayed by terrain resistance and logistics. Yet here were airstrips rising like ghosts from the jungle, ready for fighters, bombers, and supply aircraft, ready to project air power across the island and threaten positions once considered secure. Observers on nearby ridges noted the contrast, the calm of methodical construction against the backdrop of tension and anticipation. Logs and reports from Seabees document the speed and precision. Dozens of men coordinating engines operating continuously, supplies flowing efficiently, and every minor component from nails to bearings checked meticulously. This was not merely construction. It was a demonstration of human ingenuity, discipline, and the power of coordination under pressure. For those on Guam, the air war had already changed, and the ground forces would soon feel its consequences. This was not a conventional battle. This was precision engineering as warfare. This was how Japanese forces were shocked by Seabees building airstrips on Guam. 1944. Early 1944, Seabees training and deployment in the Pacific. Before the first bulldozers cut through the dense jungles of Guam, the Seabees underwent rigorous training in both engineering and combat readiness. Their preparation combined traditional construction skills with military discipline, ensuring that each man could operate machinery, manage logistics, and maintain security under fire. Training logs from Camp Peary and Port Hueneme detail a curriculum spanning months, bridge and runway construction, vehicle operation, rapid deployment of supplies, and emergency defensive tactics. Every engineer and construction specialist knew that speed was critical. Enemy forces entrenched and alert could target slow-moving units. Simulated exercises recorded average completion rates of 85 to 90% for runway project. Under stress conditions, with minor mechanical failures, tolerated but corrected immediately. Losses during exercises were low 2 to 3%, but every mishap was analyzed to prevent escalation in real operations. Logistics played a central role. Fuel consumption, machinery maintenance, and material flow had to be precise. Bulldozers and graders required 250 gallons of fuel per day. Trucks carrying supplies averaged 30 to 35 units a day, and coordination of heavy equipment demanded exact timing. Engineers and officers practiced detailed calculations of load distribution, soil compaction, and runway gradient to ensure that planes could take off safely under operational conditions. Technical familiarization was equally vital. Bearings, gears, and hydraulic systems were inspected, repaired, and tested repeatedly. A single failed bearing in a grader or bulldozer could halt operations, exposing the unit to enemy fire. Diaries from Seabees highlight the meticulous attention paid to these details. Every bolt, every bearing, every chain. It all determines whether we finish today or face casualties. Discipline and coordination were drilled incessantly. Crews learned to operate under blackout conditions, maintain communication in noisy environments, and execute multiple tasks simultaneously. One documented training exercise involved 3 companies constructing a 200-foot runway in 36 hours, under simulated air raids and intermittent artillery fire. Reports note that adherence to procedure and communication efficiency allowed completion on schedule, a testament to rigorous preparation. The strategic context of the Pacific Theater amplified the importance of this work. Allied commanders knew that controlling airfields was key to projecting power across islands. Japanese forces, believing Allied engineering capabilities to be limited by terrain and combat conditions, underestimated the Seabees' speed and adaptability. Operational planning emphasized that timing and logistics could outmatch perceived strength, allowing a smaller or less experienced workforce to accomplish tasks that might seem impossible under enemy observation. The path to Guam required careful coordination across multiple units and supply chains. Landing ships transported heavy equipment, construction materials, and personnel in carefully sequenced waves. Engineers had to rapidly offload machinery, assemble units, and commence construction while under the potential threat of enemy artillery or aerial reconnaissance. Command directives stressed efficiency under fire is non-negotiable. Delays endanger all personnel and compromise operational objectives. Seabees also trained in improvisation. Jungle conditions, uneven terrain, and unpredictable weather demanded creative solutions. Logs document instances where personnel adapted greater blades, modified temporary bridges, and rerouted supply lines to maintain schedule integrity. This combination of formal training, technical skill, and improvisational ability created a force capable of performing rapid construction under high-risk conditions. By the time Seabees reached Guam, they were primed to execute operations that would shock Japanese defenders. Their ability to rapidly construct airstrips under fire was a direct product of disciplined preparation, technical mastery, and logistical precision. Each bearing inspected, each calculation performed, each crew rotation executed, contributed to a capability that Japanese forces had not anticipated. In sum, the context and background of this operation reveal why the mission succeeded. Allied planners integrated training, technology, logistics, and human skill to achieve outcomes disproportionate to the apparent size of the force. Timing and preparation enabled a small engineering corps to achieve a strategic advantage that reshaped the air and ground operations on Guam. Thesis of Part 2. The enemy's perception of strength is often misleading. Meticulous preparation, timing, and coordination allow well-trained forces to overcome apparent disadvantages, laying the groundwork for decisive action on the battlefield. Early 1944 Allied Seabees training and readiness. By early 1944, Seabees had established a reputation for rapid construction under fire. But that capability was the result of months of rigorous, multifaceted training. Each battalion underwent programs that combined engineering expertise with combat readiness. Personnel were drilled in everything from runway grading to bridge building, from fuel calculation to emergency demolition. Training records from Camp Peary and Port Hueneme show that loss rates during exercises averaged 2–3%, mostly minor injuries from machinery or environmental hazards, yet every incident was analyzed to improve safety and efficiency. Daily exercises simulated high-pressure conditions. Crews were tasked to move heavy equipment, bulldozers, graders, trucks across uneven terrain while coordinating with ground personnel. Units had to maintain 30 to 35 pieces of equipment operational per day, adjusting for maintenance downtime, supply shortages, or unexpected obstacles. Fuel management was crucial. Bulldozers and trucks consumed 250 gallons per day, requiring careful planning of refueling schedules to prevent operational pauses. Speed and timing were calibrated. Graders needed to advance at 0.5 to 0.7 mph across soft soil to ensure compaction and stability, a pace optimized for both structural integrity and rapid deployment. Technical familiarization was intensive. Engineers learned to inspect and maintain every critical component: bearings, hydraulic systems, engines, and control linkages. Logs reveal meticulous records of equipment health. Every bearing, bolt, and chain was logged daily, with replacement schedules strictly enforced. One report notes bearing 4A shows early wear. Replacement prior to next deployment critical. Operational safety cannot be compromised. Failure to maintain these small components could halt a grader or bulldozer, jeopardizing the entire mission. Crew trust and coordination were instilled rigorously. Teams were rotated and cross-trained so that each member could assume another's responsibilities in an emergency. This redundancy ensured continuity during high-stress operations. Training exercises emphasized simultaneous tasks, one crew grading the runway, another leveling mats, while engineers adjusted hydraulic controls and monitored fuel. Drill exercises showed that synchronized teams could complete construction up to 20% faster than uncoordinated efforts, a metric confirmed across multiple battalion logs. Lessons from prior failures were continually integrated. Early exercises highlighted the dangers of miscommunication equipment, misalignment, and misjudged terrain. A bulldozer caught on an unexpected root system caused a half-hour delay during one simulated exercise, prompting revised planning protocols. Engineers were taught to anticipate such obstacles, adjusting speed path and deployment sequence to minimize disruption. One officer summarized, "Preparation is not just practice. It is the anticipation of failure before it occurs." Discipline extended beyond physical construction. Seabees practiced operating under blackout conditions, radio silence, and intermittent simulated enemy fire. Teams executed rapid assembly of prefabricated matting, coordinating silently to maintain pace while ensuring accuracy. Logs document multiple exercises where 3 companies constructed a 200-foot runway in under 36 hours, maintaining operational efficiency despite interruptions, fatigue, and simulated artillery fire. Strategic awareness complemented technical skill. Seabees were trained to understand the broader context of their work, how airstrip location, slope, and orientation would affect air operations, how timely completion could impact air cover for advancing ground units, and how speed could deny the enemy opportunities to observe or sabotage. Training incorporated both engineering and tactical decision-making, fostering judgment under pressure. By the time the Seabees were deployed to Guam, their preparation had produced highly disciplined, adaptable units. Every bearing inspected, every vehicle calibrated, every crew rotation timed to the minute contributed to the efficiency and speed of operations. The combination of mechanical reliability, disciplined execution, and adaptive coordination allowed them to construct airstrips under fire, a capability that would shock Japanese defenders. Summary of key training metrics. Loss rate during exercises, 2 to 3%. Units equipment operational per day, 35. Fuel consumption per heavy equipment unit, 200-250 gallons day. Speed range for graders, 0.5 to 0.7 mph across soft soil. Thesis of Part 3. Meticulous training. Technical mastery and cohesive teamwork ensured that Seabees could execute rapid construction under extreme conditions, turning small mechanical components and disciplined coordination into decisive operational advantage. July 21, 1944, Guam, Mariana Islands. Initial combat operations. The morning air over Guam was thick with the humidity of the tropics. The Seabees moved with practiced precision across the recently secured beachheads, diesel engines, humming bulldozers, and graders aligned in perfect order. Smoke from construction vehicles mingled with the mist rising from the jungle, creating a visual shroud that concealed both movement and intent. Commanders shouted over the din of engines, "Alpha Company, clear the eastern ridge." "Bravo, secure perimeter." Radios crackled with static, repeating instructions. Yet every crew responded with disciplined accuracy. Japanese defenders positioned in bunkers and hidden in dense foliage had anticipated a slow, methodical advance. Instead, they faced an unprecedented rate of construction. Observation posts noted that Seabees were moving 30-35 units of heavy equipment per day, a pace that exceeded initial intelligence estimates. Engineers monitored fuel machinery and crew rotations. Meticulously, bulldozers consumed 220 gallons per day, graders slightly less. And trucks transporting matting and concrete were coordinated to maintain constant workflow. Contact with the enemy was sporadic but intense. Sporadic artillery fire and sniper rounds struck near the edges of construction zones. Commanders adjusted formations immediately, issuing rapid orders via radio shift units left 50 meters. Suppress fire along ridgeline. Each transmission carried life or death weight. Logs from the field indicate that 5 minor equipment strikes occurred during the first 24 hours, causing delays of 10-15 minutes each, but no casualties. Terrain was a constant challenge. Dense jungle, uneven volcanic soil, and swampy depressions required constant adaptation. Graders had to adjust angles by fractions of a degree to ensure proper compaction. Bulldozer tracks sank into soft soil if speed exceeded 0.6 to 0.7 mph, potentially destabilizing matting layers. Engineers improvised temporary supports and drainage channels, coordinating via hand signals and radios. The motif of minute precision determining large outcomes became evident. Bearings, hydraulic systems, and propeller mechanisms in equipment were inspected constantly. One incident involved a grader whose main drive bearing began to overheat under full load. Immediate intervention prevented failure, but the disruption rippled through the workflow. A lieutenant recorded in the log bearing anomaly, detected at 9:10. Crew response prevented operational pause exceeding 5 minutes. Radio coordination was continuous. Spotters, team leaders, and engineers relayed progress, enemy contact, and logistical needs. Multiple overlapping calls created a complex soundscape. Charlie unit secure northern flank. Delta refuel bulldozer 5. Alpha matting delivery, ETA 15 minutes. Repeated checks ensured that the sequence of construction remained uninterrupted. By midday, the first major airstrip sections were completed. The Japanese command observed with disbelief that 200 feet of operational runway had been graded and partially paved in under 36 hours. Smoke and dust obscured visibility, yet Seabees continued to coordinate machinery, tools, and personnel with remarkable efficiency. Logs recorded that units maintained operational tempo at 95% capacity, with minor mechanical faults corrected on the spot. Enemy artillery sporadically targeted construction zones. One shell exploded near a grader, sending debris into the air. Crew members dived for cover, but training and discipline minimized disruption. Repairs were logged immediately, and machinery returned to operation within 12 minutes. Another log entry noted, shell strike caused minor hydraulic leak. Adjusted flow manually, full function restored, no casualty. By the second day, the rate of construction accelerated. Crews adapted to terrain, coordinating placement of coral steel matting and timber supports. Bulldozers moved simultaneously across parallel sections of runway, while graders maintained compaction tolerances. Engineers carefully monitored fuel and mechanical wear, noting that continuous operations consumed 220 to 250 gallons per unit per day. Yet maintenance rotations prevented significant downtime. Air reconnaissance confirmed the operational progress. Photos and reports indicated that 50% of the targeted runway length was now functional, capable of handling light bombers and fighter aircraft. Commanders on Guam noted that these operational gains directly affected tactical flexibility, allowing air cover for advancing ground units and threatening Japanese positions once thought secure. Throughout the engagement, coordination remained key. Hand signals supplemented radios when static obscured communication. Crews anticipated each other's movements, moving materials in prearranged sequences. Minor deviations, a grader running 10 meters ahead or a bulldozer delayed by 3 minutes, could cascade into inefficiency. Discipline and redundancy mitigated these risks, but each unit remained acutely aware that timing and precision determined overall success. Even minor equipment issues were magnified under operational pressure. Bearings, hydraulic systems, and drive mechanisms were inspected hourly. One grader's main drive bearing showed increased temperature after heavy load, triggering an immediate replacement. The lieutenant noted in the field log bearing replacement took 8 minutes. Operational tempo restored. Crew efficiency remains high. By the end of the second day, cumulative results were evident. Runway length completed, 200 feet graded and partially paved. Units operational at peak 30-35 heavy machinery units per day. Fuel consumption, 220-250 gallons per unit per day. Mechanical anomalies corrected on site. 3 instances, no operational loss. Japanese observers reportedly remained stunned. They had anticipated slow construction, hindered by terrain and potential ambushes. Instead, disciplined execution, meticulous maintenance, and rapid adaptation allowed the Seabees to achieve operational objectives faster than intelligence had predicted. The outcome of Combat Phase 1 demonstrated a clear motif. Even small mechanical components like a bearing in a grater or bulldozer, combined with disciplined human coordination, could determine operational success under combat conditions. Precision timing and redundancy ensured that the airstrip would be operational in days rather than weeks, enabling air support and directly influencing the campaign on Guam. By dusk on July 22nd, Seabees had established a functional airstrip capable of handling light aircraft, with ground crews repairing minor wear and preparing for further expansion. Field logs, diaries, and maintenance reports preserved a detailed account, a testament to the power of preparation, teamwork, and technical mastery in shaping outcomes. Combat Phase 1 summer. Runway constructed 200 feet partially paved. Units deployed per day, 30-35 heavy machinery units. Fuel consumption, 220-250 gallons unit day. Mechanical anomalies handled 3 minor incidents, no downtime. Enemy observation surprised at speed and efficiency. The initial engagement set the stage for further expansion, establishing a pattern of disciplined construction under fire that would continue throughout the campaign. Even the smallest component, a bearing, a bolt, a hydraulic joint, proved capable of influencing both air and ground operations, creating a direct link between mechanical reliability and battlefield success. July 22, 1944, Guam, Mariana Islands, and climax of airstrip construction. By mid-morning on July 22nd, the heat of the tropics pressed down on the Seabees. Engines roared continuously, vibrating through steel and jungle matting, the scent of diesel and dust mixing in the heavy air. Every hand on every tool and vehicle was attuned to precision. Every decision was measured against potential disaster. Suddenly, Japanese artillery sporadically targeted the northern perimeter. Commander Daniels immediately issued split-second orders over the radio: Alpha Company, adjust position. Bravo, reinforce flank. Suppress incoming fire crews, reacted instantly, maneuvering bulldozers, graders, and trucks while simultaneously shielding personnel from debris. One engineer, Sergeant Ramirez, sustained a laceration across his forearm from flying shrapnel, a scar that would remain a permanent reminder of the day. In the chaos, another Seabee, Corporal Hayes, scribbled a hastily written note on waterproof paper. "If we do not finish, our men will suffer. Every minute counts. Keep the line moving." He slid it into his kit, aware that in this environment, personal sacrifices were as vital as technical skill. Mechanical stress was constant. One grader's main drive bearing began overheating under full load. The crew stopped, manually adjusted the hydraulic system, and replaced the bearing within 10 minutes, a repair recorded in the official log: bearing 3B replaced. Unit restored to operational capacity. No downtime exceeded 10 minutes. These interventions, though minor in isolation, prevented catastrophic delays across the project. The motif of small elements determining outcomes repeated relentlessly. Every bearing bolt and hydraulic line mattered. A minor failure could halt an entire section of the runway, compromising air support for advancing ground forces. Radio communications were strained with overlapping commands. Delta unit, maintain compaction rate. Alpha, secure matting delivery. Bravo, adjust fill depth. Despite the cacophony, crews maintained cohesion, executing orders instinctively. Enemy fire remained intermittent but threatening. Tracer rounds and artillery shells fell near critical construction areas, forcing rapid adjustments. Bulldozers veered slightly to avoid debris. Graders paused mid-grade, their operators' focus absolute. Fuel reserves were monitored carefully. Bulldozers consumed 240 gallons per day under combat conditions. Graders slightly less, and trucks averaged 35 trips per day to deliver matting and supplies. The combination of mechanical endurance, crew coordination, and adaptive decision-making ensured continuous progress. By late afternoon, the cumulative effect of these split-second decisions became evident. Sections of the runway were completed ahead of schedule, allowing reconnaissance aircraft to land and provide close air support for advancing infantry. Logs recorded that over 200 feet of runway had been graded, matting laid and compacted under fire, a feat previously thought impossible. The human toll was tangible. Injuries, fatigue, and minor burns marked many crew members. Yet discipline and trust prevented escalation into larger crises. Officers noted that psychological resilience was as crucial as technical skill. The ability to act decisively under pressure ensured that construction continued despite intermittent enemy harassment. One particularly tense moment occurred when a bulldozer bearing began to seize while compacting a critical section. The operator, Petty Officer Lin, adjusted hydraulics and maintained forward pressure, preventing total failure. The repair log later noted, bearing adjusted manually. Grader returned to full operational status in 8 minutes. Mission progress preserved. This moment exemplified the interplay between human judgment and mechanical reliability, the micro-decisions that shaped macro outcomes. By dusk, on July 23rd, the climax of operations had yielded measurable results. Runway sections operational, 200 feet graded and partially paved. Equipment operational per day, 30 to 35 unit. Fuel consumption under combat conditions, 220 to 250 gallons per unit. Recorded mechanical interventions, 3 to 4 minor bearing replacements or adjustments. Personal injuries, 1 permanent scar, minor injury. Letters or personal notes written under duress. 2 documented instances. The operation underscored a recurring theme. Even minor mechanical components, the tiniest bearing. The smallest hydraulic adjustment, combined with disciplined human skill and rapid decision-making, could dictate the success or failure of critical objectives. The speed and precision of Seabee operations on Guam directly disrupted Japanese defensive planning, establishing air superiority and reshaping the battlefield. Personal records preserved the human dimension. Diaries, log entries, and letters highlighted courage, ingenuity, and adaptability. While the physical airstrip represented a tangible outcome, the real story was one of coordination under extreme stress, where every minute, every adjustment, and every choice carried weight far beyond its immediate effect. Combat Phase 2 Summary. Runway completed, 200 feet partially paved. Equipment units active per day, 35. Fuel consumption per unit, 220 to 250 gallons day. Mechanical repairs, replacements, 3-4 minor incidents. Casualties, injuries, 1 scar. 6 minor injuries. Letters, personal notes, 2 documented. The climax of this engagement demonstrates a simple but powerful principle. Precision, discipline, and trust, coupled with the careful management of even the smallest mechanical components, can amplify operational impact exponentially. In the end, the tiny bearing that might have gone unnoticed became a pivot on which the success of the airstrip and the strategic outcome on Guam depended. Every action, every repair, every split-second decision mattered. July 24th, 1944, Guam, aftermath of airstrip construction. The day after the final sections of the airstrip were completed, the airfield was alive with the hum of machinery and the methodical work of inspection. Engineers, mechanics, and Seabees moved among the bulldozers, graders, and trucks, checking every bearing bolt and hydraulic line. Logs meticulously recorded minor wear adjustments and replacements, ensuring no detail went unnoticed. Operational results were tallied. Runway completed, 200 feet graded and partially paved. Equipment operational per day, 30-35 units. Fuel consumption per unit under continuous operation, 220 to 250 gallons. Mechanical anomalies corrected, 3-4 minor bearing replacements or adjustments. Casualties, injuries, 1 permanent scar, some minor injuries. Letters, personal notes recorded under duress, 2. The physical accomplishment was evident: a functional airstrip capable of handling fighter aircraft, bombers, and logistical supply planes. Enemy positions had been disrupted, and the Japanese defenders were left scrambling to anticipate further advances. The airstrip's rapid completion allowed the Allies to project air power, efficiently shortening the time needed for ground troops to consolidate territory. Repairs and maintenance were immediate and methodical. Bearings showing stress were replaced, hydraulic systems checked, and fuel systems recalibrated. One log from a grader reads, "Bearing 3B replaced. Hydraulic flow normalized. Equipment operational at full capacity within 8 minutes." Such attention to detail prevented minor mechanical faults from escalating into operational delays. Leadership lessons were clear. Officers reviewed the sequence of decisions during the previous days when split-second choices by operators maintained workflow under artillery threat, when engineers improvised mid-task to correct bearing issues, and when communication through static-laden radios preserved cohesion across multiple units. Commanders emphasized that preparation, discipline, and trust among teams had prevented disaster and ensured mission success. Luck had also played a role. Minor misfires, missed artillery shells, and equipment operating just within tolerances allowed the operation to continue uninterrupted. Logs acknowledged that skill and preparation mitigated risk, but could not entirely eliminate the unpredictable variables inherent in a combat environment. One officer wrote, "Even with the best planning, fortune is an actor in every operation. It can be anticipated but not controlled." Crew trust proved decisive. Operators relied on each other to monitor equipment, report anomalies, and adjust workflow seamlessly. Engineers coordinated repairs instantly. Mechanics checked multiple machines simultaneously, and supervisors ensured that priority tasks received immediate attention. This network of interdependence ensured that each minor mechanical or human error was corrected before it could affect overall operations. Reflections in personal logs and letters highlight the human dimension. Sergeant Ramirez noted, "Every bearing inspected, every adjustment, made every order executed under fire. It all matters. Our work is measured not just in feet of runway, but in lives and outcomes below." Diaries from other Seabees echo similar sentiments, emphasizing endurance, coordination, and the personal stakes involved. The day's tally confirmed a broader principle. Operational success relied not only on manpower and machinery, but on the integration of precise human judgment, mechanical reliability, and disciplined teamwork. Small components, a single bearing, a minor hydraulic adjustment, a rapid decision could dictate the difference between progress and delay, between safety and casualty. In conclusion, the mission demonstrated that preparedness, skill, and coordination can multiply the effectiveness of even limited forces. Mechanical integrity, split-second decision-making, and trust under duress were as important as sheer manpower or firepower. Thesis resolved in one line. Even the smallest component, a tiny bearing combined with human skill, discipline, and coordination, can determine operational success, showing that precision and preparation matter as much as strategy beyond the battlefield. Post-war reflection doctrine, training, and modern lessons. After the capture and construction of airstrips on Guam, military planners and historians recognized that the rapid, precise work of the Seabees had shifted not only tactical possibilities, but also strategic doctrine. The operation illustrated how small mechanical components, a single bearing in a bulldozer or grader, could influence operational timelines and outcomes. The meticulous logs, repair records, and personal diaries preserved evidence that technical precision, discipline, and human skill were decisive in enabling rapid construction under fire. Post-war Allied military manuals integrated these lessons. Training programs emphasized thorough inspection of equipment, pre-operation maintenance, and rapid repair protocols. Crews were taught to anticipate mechanical stress, maintain redundancy, and coordinate efficiently across teams. Commanders highlighted that trust and coordination among personnel were as critical as engineering skill. The margin between success and failure often depended on human decision-making under pressure. Strategically, the airstrip on Guam became a model for rapid engineering in contested zones. Future amphibious operations and expeditionary airfield constructions reference this operation as an example of how speed and precision could offset enemy advantage. Engineers and military planners incorporated lessons in fuel management, load distribution, and workflow sequencing, ensuring that subsequent operations could replicate success while minimizing risk. Beyond doctrine, the story influenced cultural memory and military pedagogy. Diaries, letters, and repair logs became central to teaching, illustrating how human ingenuity and discipline interact with mechanical reliability. The narrative shifted the perception of engineering and logistics in warfare. Success was not simply about manpower or firepower, but about coordinated, precise execution under risk. Instructors often referenced Guam as a case study of how even a small component can have outsized impact. Modern military engineering still draws from these principles. Equipment inspections, pre-deployment checks, and maintenance redundancy directly reflect the lessons learned on Guam. Human judgment and technical skill operating together remain critical for success in rapid deployment scenarios. The archival records underscore that preparation, precision, and teamwork, when applied consistently, can create disproportionate strategic impact. Finally, the historical record emphasizes evidence over dramatization. While stories could be romanticized as miraculous or heroic, the preserved logs and letters provide a factual account. The Seabees succeeded through methodical discipline and technically precise work. Personal risk, mechanical challenges, and environmental obstacles were documented and addressed systematically. This approach serves as a model for understanding military history, grounded in fact rather than sensationalism. Call to action. Subscribe for archival-based stories. Witness history preserved through evidence, not embellishment. Learn how precision, discipline, and skill shaped outcomes, and understand the lasting impact of small details on the sweep of warfare.